Alright guys, so let's get started with the session here. Right, so I hope many of you were there in our previous session where we had talked about this. We have built an app for the Titanic classifier using logistic regression model. Alright, so here today as well we are going to do the same thing. So we have divided this session into three parts today as well. Alright, so the first part is going to be your theory part, and the second part will be the model building part, and the third part is going to be your building a web app for our whatever model that we have built. All right, guys, so let's get started. First of all, make sure that you have watched the previous session. If you don't have watched the previous session, don't worry, it is going to be easier as well. All right, so let's get started here, and here we are going to talk about the decision tree first. All right, so here let's move forward and we are going to talk about the decision tree here. All right, so what is decision tree? So a decision tree is a supervised machine learning algorithm. All right, so it is a supervised machine learning algorithm. We know the labels of our classes. All right, so this is our decision tree is a supervised machine learning algorithm. It is used for both classification as well as regression problems. All right, so it can be used for classification as well as regression, whether we have these numeric values to predict or the categorical values to predict. It can be used for both. It is mostly used for classification tasks, but if you see the real implementation of decision tree, it is mainly, we use this mainly for the classification task. You can use it for regression, but most of the application of decision tree are based on this classification. All right, so here the goal of the decision tree is to build the model to predict the value of target label. All right, so we want to predict the target label, that is our class here, and we want to build this model by inferred simple decision rules from our data. Now what do we mean by this simple decision rules and how it is inferred? All right, so here let's see an example of this decision tree over here. Here is a decision tree. So we want to find out whether a person is fit or not fit. All right, so here what is the task? Task is whether a person is fit or not fit, and here we have different features. All right, so we have age, and we have this whether this person eats pizza or not. So here we are checking at the root node, we call this as root node. We are checking what is the age, whether the age is less than or greater than 30. All right, so we are checking whether the age is less than 30. If yes, does the person eat a lot of pizzas? All right, and here if no, then does the person exercises in the morning? So if he exercises and he is greater than 30 years of age, you can classify him as fit, right? And if he is not exercising in the morning, then you call that person as unfit here. All right, and here as well, you see we are making this simple decision at each node. We are splitting this data and dividing this further into different sub node by taking some decisions, right? So this is your example of a simple decision tree, and we will talk about how we build this tree, what is the method of this splitting. All right, we are going to talk about that now. First of all, before moving forward, let's get familiar with some of the terminologies of this decision tree. So there are many terminology. To not get confused, we are going to clarify those terminologies first. All right. So all right. So here we see this a simple decision tree. So here it is a simple decision tree, and if you see, we have marked this root node, decision node, right, and terminal node. Now let's talk about this. What is root node? What is decision node? And what are these terminal nodes? And here we have this depth as well. So at root node, before any kind of splitting, we have our all data, right? So at root node is where our population data is present before any splitting. So before any splitting, you have all of your data in this root node. So this becomes your root node, which is in orange here. All right. And after splitting it, you call these nodes as decision node. So here the decision nodes are marked with red color. Here you see this decision tree node, marked with this red color. So when a subnode, so this is a subnode of this root node, right? So this is a subnode, and when this subnode get further divided into different subnodes, then we call this as decision node here. So this is our decision node. So here it is getting divided into two different subnodes again, and here if you see, we have 3 decision nodes. All right, so we have 3 decision nodes. So whenever a subnode gets further divided into different subnodes, then that becomes your decision node. And let's talk about what are these terminal nodes. All right, so here a node which does not get divided further into subnodes or different subnodes is known as leaf or terminal node. So here if you see all these marked with the green color, there is no further splitting, right? There is no further splitting. So here it is your terminal node or leaf node, after which there is no further splitting. All right, so let's move forward and see what is this depth. So what is depth? Depth is the longest path from root node to the leaf node. So here if you see, what is the longest path that we have to take to reach from this root node to the bottom of this tree here. All right, so what is the longest path? And that longest path is our depth. So here if you see, this is the first, then second, then this is the third. So depth of the tree is 3 here. All right, so this is your depth, that longest path from root node to the leaf node. Then we have something called as splitting, right? So splitting is the process of dividing a node further into different subnodes. So this is very easy to understand, right? Splitting process. We are splitting this decision node into different subnodes. All right. Now there is something called as pruning. Now what is pruning here? Pruning, it is opposite of splitting. In splitting, what we used to do, we used to divide these subnodes into different subnodes, right? So you have this decision node, then you divide it, then you have terminal node, right? And here in pruning, it is opposite of splitting. When a tree is fully grown, you remove the subnodes. Here, for example, let's consider if you remove this terminal nodes from here, this becomes your pruning. All right, so if you remove this, then you have done the pruning here. After growing your tree fully, you have removed some of the nodes. So this is all the terminologies that we are going to use. So this was just to make you familiar with all these terminologies. All right, now that we are familiar with terminologies, let's move forward and see how it really works at the under the hood, how this really does the job here. All right. So decide the best split in decision tree. How do we decide the best split? How do we know that there are many features in our data set, right? We have, let's consider if you want to have this data set where you have attendance is greater than 80, and you also have another feature which is attended test 1, and here you have this pass. All right, so here what we are trying to do is we are trying to build a decision tree to classify them into different subgroups. That is, you have the data set of these students, and you have also been given this information whether the student attended the 80% of classes, more than 80% of the classes or not, and you are also given whether the student has attended test 1 which was conducted or not, and also you have the classes here, which is 1 if the student has passed and 0 if the student has failed here. All right, so here we want to build a decision tree to classify them into different subgroups, that is pass and fail. So here we have total 20 number of data points. All right, so we have 20 number of data points here, and out of this 20, 12 have passed and 8 have failed here. All right, so if you count here the zeros and 1, then 1 is going to be 12 times and 0 is going to be 8 times. Now how do we know that you have to split the, whether we should do the splitting first based on this attendance or this test, right? How do we know that? So let's move forward and see that here. So here I can have this decision tree where first split we are doing based on this attended test. All right, and then it further gets divided, and at the second splitting time we are taking this attendance here. All right, and here you can also have this tree, right, where the first splitting is done on this attendance, then the second splitting is done on this attended test 1. So we have this two, we can have these two trees, right? If there are n number of features in your data set or n number of columns, then you can have n number of possible decision tree. Now how do we decide, or how does the decision tree that we implement decides under the hood which variable to consider for the splitting first, right? So how do we consider that? How do we do that? So there are, how do we decide on which variable to split first, right? So let's move forward and see that. So a decision tree uses multiple algorithms to decide to split a node into different subnodes. So there is a algorithm that is working under the hood to decide this best split, or consider the best feature for your first split, then your second split, then your third split. All right, and so a decision tree split the nodes on all the available variables. So a decision tree is going to split the nodes on all the available variables and then going to select the one which result in more homogeneous nodes. What do we mean by homogeneous nodes? So homogeneous nodes means pure node, right? What is pure node? If there is just one single class, all right, either fail or pass, then it becomes your pure node. This is your homogeneous nodes. All right, the goal of any learning algorithm in decision tree is to find the best split. If you find this best split, then your job is done. All right, so there is two type of algorithm that we use mostly, which is Gini and entropy. Here we are going to talk about the Gini only. Entropy is simple, you can refer online materials, all right, and you will get it. Here we are going to talk about the Gini. all right, and we will see how this splitting happens. And same you can think of this entropy as well, all right. So the task of both of this algorithm which you see here, that is Gini and entropy, is to have, after splitting, have more homogeneous nodes, all right. So let's talk about this Gini now. Now Gini says, so here Gini says, if we select two items from a population at random, then they must be of same class and probability for this is 1 if the sample is pure. So here please pay attention, we are saying if we select two items from a population at random, they must be of same class and probability for this is 1 if your sample in that particular node is pure. So here let's consider this example. So here we have all these blue points, right? So we have all the blue points and there is no other data point or any other color, right? We only have blue points in this node. So this is our pure node. Now if I tell you to select any 2 points from this pure node, and if I want you to find out what is the probability that it belongs to this blue color, then the probability is going to be always 1, right? Because you have this pure node. So if we select any 2 points at random, they will be of same class and probability that they belong to the same class is 1 because our node is pure here, right? And here I have some impure nodes. So here we have blue circles as well as red circles. So we have introduced some impurity here, all right. So here if I tell you to select any 2 points, then find out the probability that they belong to same class, then here it is not going to be 1, right? Here you have two probabilities. There is going to be probability for your blue class and probability for your red class, right? So here you give this Gini equals to p square, that is probability of, let's say, red circles plus q square, that is probability of your blue circle. So you have this Gini equals to p square plus q square. Now using this Gini, what we do is we try to find out the impurity at this particular node. So here we have Gini impurity equals to 1 minus Gini, and we call this as Gini impurity, and this value tells you what is the impurity at your node or how pure your node is. If your Gini is high, so here if your Gini is high, then your Gini impurity is going to be low, right? So we want this Gini impurity to be as low as possible to have a pure node. So let's calculate this. So let's consider our example and let's split it on first, that is attended test. So here we are doing this first splitting on attended test, then we will also look for the split on attendance, all right. So here we have this split on attended test, and here we have this values in root node. So here the red circle represent that the students have failed and the blue circles represent that the students have passed, all right. So here the total data point is 20 and there are 12 pass, that is blue circles, and 8 fail, that is red circles, right? And here if we divide this on attended test, so here you have this probability of pass and probability of fail. So what is probability of pass? It is going to be 12 by total, right, which is 12 by 20, which comes out to be 0.6 here. Again, what is the probability of fail? So probability of fail is equals to 8 by 20. So how many students have failed in this particular node? It is 8, right? And here is your total. So you have probability of pass and probability of fail. All right. Now we can calculate this Gini, right? Which is p square plus q square. So here it is your p square, which comes out to be 0.6 square plus 0.4 square. So this is your Gini, and if you do the mathematics here, it is going to be around 0.52. So here it is your Gini. Now we can find the impurity at the root node without any splitting. So this is the impurity at root node without any splitting. All right. So here the impurity is 1 minus Gini, which comes out to be 0.48. So this is our impurity here. Now let's divide this or split this into attended test or not. All right. So we have yes, and here now if you see, after splitting, you have total of 12 data points in this left subnode. Alright, so total, if you consider this red and blue points as well, then total is 12 now after splitting in this left subnode, and pass equals to 9. So what is pass? Your blue circles, and fail equals to 3 here. Alright, again you have to calculate the Gini at this subnode. Alright, so we calculate this probability of pass and probability of fail here. So here it comes out to be 9 by 12, which is equals to 0.75, and probability of fail equals to 3 by 12, which comes out to be 0.25. Alright, and here again let's calculate the Gini. So Gini is 0.5 square plus 0.25 square, and which comes out to be 0.625. Now that we have calculated the Gini for left subnode, you can easily find the impurity at this subnode, left subnode, right? And impurity is going to be 1 minus 0.625, which comes out to be 0.37. All right. Now we have calculated this impurity for left subnode. Now let's calculate the impurity for the right subnode. So here is our impurity at right subnode. So here after splitting at right subnode, we have total of 8 data points. Out of 8, 3 have passed this examination and 5 have failed this examination. Again you have to repeat the same process. So here you have to calculate the probability of pass, probability of fail, which comes out to be 3 by 8, that is equals to 0.38, and probability of fail is 5 by 8, which comes out to be 0.62. Again calculate the Gini using p square plus q square and calculate the impurity. So here you have calculated the impurity at the root node, we have calculated the impurity for this left subnode, and we have calculated the impurity for this right subnode. Alright, now what should be our next step here? So here if you see, we take the weighted Gini impurity for this left subnode and right subnode, and this weighted Gini impurity should be less than what we have got at the root node. What was the impurity at root node? It after splitting this value should come down. So how do we calculate this weighted Gini impurity, right? So here is the formula. Alright, so we have this weighted impurity equals to 12 by 20. What is this 12 by 20? So 12 is the total number of data points in your left subnode divided by your total number of data points in the root node. So here it is 12 by 20 into Gini impurity at that node. So here it is our left subnode, right? So here it is 12 by 20 into 0.37, and plus you have to do the same thing for this right subnode. You have to take the weighted Gini impurity at this right subnode, and if you add this to the weighted Gini impurity for this split on attended test is coming out to be 0.42, and at root node we have this impurity as 0.48. So our impurity has decreased after splitting this on attended test here, right? So we have decreased this impurity. Now let's move forward, and also you have to calculate this for split on attendance greater than 80. So we are going to calculate this for attendance now, and you have to repeat all the steps that we have covered for this split on attended test. All right, so here again calculate this impurity at root node. So we have already calculated it, right, which comes out to be 0.48. we have seen it, and now let's split this. So we have split this on attended, sorry, this is attendance greater than 80. All right, so you have this left subnode, and here you have total of 10 data points after splitting, and here the pass is 6 and fail is 4. So you can calculate the probability easily, and after calculating probability of pass and probability of fail, also you can calculate the Gini easily now, right? So here it is. So you have calculated this Gini, which comes out to be 0.52. All right, now again you calculate the impurity at this left subnode, and you calculate this impurity at the right subnode. All right, so you have this impurity at left and right subnode. We have calculated this. All right, and now again you have to take the weighted Gini impurity here. So here you calculate this weighted Gini impurity equals to 10 by 20. All right, this is for left subnode, and here it comes out to be 10 by 20 into 0.48. So what is 10? 10 is the number of data points in your left subnode, and 20 is the number of data points in your root node into your impurity at this left subnode plus 10 by 20. So what is 10? 10 is the number of data points, so total data points 10 in your right subnode divided by 20, which is total number of data points in your root node, into the impurity at this right subnode. And here if you see this, after splitting on this attendance, our impurity, weighted impurity is 0.48, and at the root node also we had this impurity 0.48, right? So both of them are same. After splitting, our nodes are not getting pure or not getting homogeneous. So what we do is we consider this split on test as our first split. This is our best split. Why? Because if you see here, so let's compare these two. So Gini impurity for split on attended test was 0.41, right? And Gini impurity for split on attendance is coming out to be 0.48 here, right? And here if you see, the impurity is less if you split this on attended test. All right, so we are going to consider this as our first split. Then this process is repeated until your tree has been grown fully. All right, so after each split, this is the same process which is going to be repeated again and again till you have a full grown tree. All right, so this is your splitting criteria for decision tree. And here we have talked about only Gini impurity. So if you go for entropy, only the formula changes, but the concept is same, that your nodes after splitting should become more homogeneous. All right. So let's move forward now, and we have seen how to do the splitting, how to form this decision tree, right? Now let's talk about some of the advantages and disadvantages of this decision tree. So first of all, let's look at the advantages. So here, decision trees are simple to interpret and visualize, right? You can visualize it easily, and you just have to write what decision you are taking and how you are splitting, right? So this is very simple to interpret and visualize. It requires less effort for data preparation compared to other algorithms. So here you don't have to specifically find out the missing values. It handles the missing values as well, and you don't have to do lot of data preparation for this decision tree algorithm. It is also useful in your data exploration. So if you build your decision tree, it is the one of the fastest way to identify your most significant variables. All right, what are most significant variables? Those variables or features which are having more impact on deciding these classes as fail or pass. All right, so this is your most significant variables, and you can see them easily by using this decision tree. So it is very helpful for this data exploration. A decision tree can handle both categorical as well as numerical variables. So we have talked about decision trees. So there is classification and regression trees as well. All right. So here you are going to, it is going to handle your categorical as well as numerical variables. And we have talked about that a decision tree can handle missing values very easily. All right. Now let's look at some of the disadvantages of decision tree. So a decision tree, the decision tree are very prone to overfitting, because if you let them grow to its full length, then it will try to classify each data point, right? So here it is very prone to overfitting. A small change in data can cause a large change in structure of your decision tree. So if you do a small change in your data set, then your decision tree is going to be most likely to change its structure. All right. Decision trees are relatively expensive, as complexity and time it takes to train this model are more. So these are some advantages and disadvantages of decision tree. I hope everyone is clear about what are decision tree, how do we decide the splitting criteria, what are the advantages and disadvantages. So we have talked all that, right? Now is the time to start coding or implementing this decision tree. So I'm going back to my Colab notebook, and we will build this decision tree on our iris dataset. Why iris dataset? Because the size is small, and if you take this decision tree, it takes more time to train. We don't want to waste our old time going to build our model, but also we want to train you, or we want you to know how it is implemented, how you can make a web app or some useful application out of your model. All right, so let's move forward. So here I'm going to go to my browser, and here I'm going to type Colab. and enter. All right, here just cancel this stuff here, and now let's have a new file. So here file, then new notebook. So I'm going to open this new notebook. Don't worry, all the files and data set will be shared with you all. Sorry. All right, so we have this notebook. We have opened this notebook. Now let's get some new code cells here. So just click on code here and you will get some new code cells. So we will be in need of this code cells as we are going to write our model, and let's connect it. All right, and let's name it as decision tree modeling. So decision tree modeling. All right, now let's move forward, and the first step we always do is import all the packages that we are going to use. All right, so we are going to import the packages. So import packages. All right, so here let me zoom in so you can have a better look. All right, so here I'm going to import pandas for data analysis as PD and import numpy as np and import matplotlib.pyplot as plt and import your cborn. So import cborn as SNS. So these are the packages we are going to use here. Let's run this by pressing shift and enter. So let's run it. All right, so always we get this warning in Colab whenever we import this cborn package. So we are getting future warning, and if you run this, there is no warning here. All right, so here in our previous session we have seen that we have to check the what version of sklearn or scikit-learn is being used here in this notebook. All right, and to check that you have to import this scikit-learn and then check the version. And here in our VS Code we have this version which is 0.23.2. all right, and also we are going to need that version of the scikit-learn package in our Jupyter notebook here. Otherwise you will face some problem when we go to build our model. All right, so make sure that whatever package you are using, it has the same version in your VS Code or whatever environment you are using, and also in your this notebook that we are going to use here, that is Colab here. Right, so here let's check that using, so from sklearn import sklearn as sk, and now let's print the version of this sklearn. So to check the version you can write sk dot underscore version and then again double underscore. All right, and if you run this, so we are using this version which is 0.22.2 here, and in our VS Code we have the version which is 0.23.2. All right, so we have to install that package. So here I'm going to write it so that you will remember. Otherwise, if you forget this, then this is going to create some problem when you are going to build your web app. All right, so make sure the version of scikit-learn you are using for Jupyter Notebook, or let's say in Colab, is same as the version we are using in our distribution. All right, so I think it has become a long one. Let me break this line here. All right, in I'm using this VS Code, which is Virtual Studio Code. And here in bracket, whatever distribution you are using. All right, otherwise you will have some problem. Now let's move forward and install this version of scikit-learn. So here, to install it, we are going to write pip install, and here you have to give -u and scikit-learn scikit-learn and equals to your version, that is 0.23.2, and run this. So it will install this version which is 0.22.2, and it will install this version which is 0.23.2. so we are getting some warning. The following packages were previously imported in this runtime. All right, no problem, we had imported this just to check the version here, right? So this is not going to create any problem. We can move forward now. The next step is we are going to read our data. So next step is read the data. All right, so let's read our data, and here you have to click on this folder icon. All right, so click on folder icon, and if you have stored this in your Google Drive, all right, so make sure you have stored this in your Google Drive. Otherwise, if you want to upload, then you can click here in this upload icon and upload it here. Then you have to copy the path. All right, so here I have this in my drive, so I'm going to mount my drive here, connect to Google Drive. All right, so here we have this drive option now. So click on this drive option, then go to my drive. Then here I have stored this data set in building a web app. Here it is iris.csv, and here I'm going to right click, then I'm going to click here copy path. So I have copied the path. I'm going to close this, and here I'm going to assign a variable data equals to pd.read_csv. right? So read_csv, because we are having this csv data, and paste our. All right, so we have pasted this folder path here. Now let's run this. So we have imported the data in our notebook. Now next step is to check the head of the data. So check the head, and here you can do that simply by using data.head function. All right, so let's give this data.head and run this. All right, so you have all this feature which is sepal length, sepal width, petal length, petal width here, and also you have this species which is iris setosa and there are three types of species in this: Iris setosa, Iris virginica, Iris versicolor. All right, we will see that how many types do we have here. So here we have this ID, it is our features, right? We have all these features: sepal length, then you have sepal width, then petal length and petal width, and based on all of these features we have to classify what is going to be the species, where it is Iris setosa, Iris virginica or Iris versicolor. All right, now let's move forward, and now let's check what is the size of this data set. So check the shape of this data set, and to check the shape, simply you can write data dot shape and run it. All right, so you have 150 rows. So the first value that you see here is your number of rows, and this 6 is your number of features. All right, so you have 150 rows and 6 features or number of columns here. Now let's move forward and see the information. So check the information now. We are going to check the information here. So I'm going to comment each step so you can refer it later. So check the information, and here to check the information you can give data dot info, right? We have this data dot info, and here you will have all the information regarding your different variables. So here the range index is from 150 entries. All right, so there are 150 entries, and this is your index number from 0 to 149. Then here the total columns that you see is 6. So we have total of 6 columns in our data set. This is our ID column, and we have 150 non-null int 64 data type, right? And then you have sepal length, sepal width, petal length, petal width, and you can check this data type, and also you can check the memory usage. So we have checked this information. Now the next step will be to check the next step. At the next step we are going to check the description. So check the description, and here we are going to check it using data dot describe. All right, and if you run this you will have the, so there is typo, it is describe. All right, so you have all the description of this data set. So you have this count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and maximum value. So you can check all of this. All right, so you can check what is the count in sepal length. So you have 150 count. Then you can check what is the mean sepal length of all these species here, which is 5.84. Then you can check the standard deviation, minimum, and maximum sepal length is 7.9. Similarly, you can check this for all other variables that you see here. All right, now we have done this. We have checked this data shape. We have had a look at this top 5 values, right? So next step will be to check if there are any null values in our data set. All right, and let's do that, and we have seen it. So here check the null values in our data set. All right, and to do that you can write data dot is null, right? And if you write just this statement here, that is data dot is null, we are going to get only true and false, right? So here we don't want this true false, You just want the sum. So how many null values are there in this ID, sepal length, sepal width, petal length and petal width? And here we can see that there are no null values. Alright, so there are no null values in our data set. Now let's move forward. Alright, now let's move forward, and here we are going to visualize some of these variables that we'll see here. Alright, so here let's go up. We have this sepal length and sepal width, right? So let's plot a scatter plot, and also let's plot this. So here we are going to see if we can separate these classes using this scatter plot. All right, so here let's take the scatter plot between sepal length and sepal width. All right, before doing that, let's convert our this target features, which is iris setosa, right? We want to get the count of this. So before plotting this scatter plot, let's have a count of them. How many values do we have in this iris? How many values are there for this iris setosa, iris versicolor and iris virginica? All right, so let's do that here. So let's take the value counts of this. Check the number of values in our, can do number of counts of different species, counts of different species in our data set. All right, so here let's do it. You can do the one way would be to write data, and here you can pass this species dot unique or value counts. You can do any of this. So here if you give this value counts, you will get the count as well. All right, so we are going to give this value counts, and here if you run this, you will able to see that you have 50 values for iris virginica. There are 50 values counts for this iris versicolor, and there are 50 count for this iris setosa. And if you want to have this using this graph, it will be more easier. You can write sns dot count plot, and here you can pass this data species, and here you have this, you have the same count for this species, different species in your data set. All right, now let's convert this into, map this into zeros and ones. All right, so here we are going to map this iris species, iris setosa, versicolor, virginica in zeros and ones. To do that, I'm going to write data, your species dot map, and here I'm going to give it as your iris setosa as 0, and then we are having this iris versicolor so we are going to map it with 1. Then we have iris virginica, and we are going to map it with 2 here, and we want to update our species. So here you have to give data, and here species. All right, so we are mapping it with zeros and ones. All right, now let's run this. I think these are in small letters. So make sure that these are small letters. And now let's check if you run this, and if you check the head of your data, so I think we have made a mistake here, a spelling mistake. That's why you get this nan values. All right, so if there is any spelling error in your naming these variables, so we have iris setosa, iris versicolor, iris virginica. So I think these are in capital letters only. All right, so be aware about that. You don't have to make this mistake here. All right, so you have to have this as your original spelling, whether it is in capital or in small letters. So I'm going to run it again. I'm going to go down and let's run this again. And now let's check the head. So again there is some mistake. I'm going to copy it directly from here only. All right, so it won't be problem then. So I'm going to copy it from here, and here I'm going to paste it. Go up. I'm going to paste this iris versicolor. And also we are going to paste this iris virginica so that we don't make any mistake this time. So let's just copy it and just paste it over here. All right, so again I'm going to run this read. So let's run it. Now let's go down. Let's run this. So here we have done this, right? So we have this converted, copy and pasted this data here, right? So let's go up, run it again, so we don't make this mistake. So let's do it here. Let's run it, and let's go down. Let's go down now, and here we are mapping it. Let's run it. Now check this data.head. Yes, now we have converted this into zeros and ones. So make sure that there is no spelling mistake, or you don't give this capitals, make these mistakes of this capital and small letters. All right, so now let's move forward. We have converted this, and now what we are going to do is we are going to plot some scatter plots. All right, so sepal length and sepal width, and see if we can separate these classes. So here we are going to have this, we are going to plot this scatter plot. PL. So we are really sorry, so there is some network issues. I hope everyone understands that. All right, so we have this scatter plot. We are going to plot this scatter plot here. All right, and here we are going to give this sepal length. So data, your sepal length, so we have sepal length cm, comma our data, and here we are going to give this sepal width cm. All right, and here let's plot this, and let's give this some title. So here we are going to give this plt dot title, and this title is going to be our scatter plot between sepal length and sepal width. right? So we have this scatter plot between sepal length and sepal width, and now let's name this x-axis, so plt dot x label, and we are going to name this as sepal length. So this is our sepal length, and our y-axis, so plt dot y label, and this is our sepal width, sepal width, right? And just to show this graph, you can write plt dot show, and now let's run this. So you have this sepal length and sepal width, but here we are not able to tell what are the sepal length and sepal width, right? Or which species is having high sepal length and which species is having low sepal length, right? So here we can do that using this color. So here let's give this C equals to your data, and here let's give it as our species. All right, and now let's run this, and here you have this species. All right, and also let's see get a color bar. All right, so we are going to have a color bar. We don't know what is this red, what is this, sorry, what is this blue, this green point represent, what does this yellow point represents, we don't know. All right, so how can we add this color bar? Or also you can add this legend, so plt dot legend. So there are no handles because we haven't added any legend or labels here. All right, so we haven't added labels, but what we can do is we can have this color bars. So plt dot can have color bar. All right, and here if you run this, if you run this here, you are going to get this color bar. All right, and now you can see this. What is this? So here it is 0. So whatever in dark we have, this is class 0 here. So this is our class 0. So what is class 0 here? It is our iris setosa, right? So it is our iris setosa. Class 0 is our iris setosa. So these are the sepal width and sepal length for this iris setosa. And if you see, it is separable from these two classes very easily, and there is overlapping between these two classes, which is iris versicolor and iris virginica, right? Now let's move forward, and like this you can do analyze all your variables, but here the main task of us is to build this model and deploy it, right? So now let's go ahead and build our model. So first of all, we are going to remove this ID from this data set, as this ID does not add any value in identifying this species here, right? So we are going to remove this ID. So to do that, let me comment this here. So here we are going to remove this ID. So delete ID from data set. All right, and here to delete it, you can add data. So data dot drop, and here you can give this as your variable name, which is ID, comma, you have to give this x is equals to 1, comma, your in place. So we have this in place equals to true here. All right, so we have data dot drop ID x is equals to 1 and in place equals to true. All right, and if you run this, you have this, you have dropped the ID. Now let's separate our, so here let's separate our dependent and independent feature. Right, so we are going to separate this dependent and independent features. So here is going to be x equals to our data dot drop, and here we are going to remove this species. So data dot drop species comma x is equals to 1 here. All right, so this is our x. Now let's get our y as well. So here is our y now. So y equals to data our species. All right, so we have this species here. Now let's run it. So we have separated this x and y. Now the next step will be to split this into training and testing. So split it into training and testing part. All right, for that we are going to use this scikit-learn package. So from sklearn dot model underscore selection import train test split. So import your train underscore test underscore split here. All right, so we have imported this train test split, and now here you have to give x train comma your x test comma your y train comma your y test here. So here it is train test split, so train underscore test split, and here you have to give x comma y, then your test size. So we are giving this test size equals to 0.2. So we are dividing this data set into training and testing here. All right, and the training part is going to have 80% of data, and testing part is going to have 20% of our data here. And here let's give this random state. So random underscore state equals to 42. You can give any value that you want. Here I have given this as 42 here. All right, now let's move forward. So let's move forward and let's run it. So press shift enter, we are getting some error here. Cannot import past version. Let me check that. So here we have from sklearn dot model selection importing this train test split, and then that's fine. Let me write this. From sklearn dot model selection import train test split. All right, let's run this. So here we are getting this error. If your import is failing due to a missing package, you can manually install dependency using either pip or apt. All right, so to view examples, so I think we have install this another version here. So we have cannot import name is past version. So there is some version problem here. Let's skip this. This is in small letter. This is it also in small letter. All right, so there is some versioning problem. What we can do is we can remove this versioning. It is going to create some problem when we move for building our web app, but we'll see that. All right, so it is not going to create much problem there. So here, from here, let's remove this and run all the cells. All right, so let's run all. So let's check this train test split in documentation. So let's go to train test split sklearn documentation. Go to this first link here, and here we have this sklearn.model selection train test split. Yeah, it is fine only. So it's fine only. Head back. So you have to start this runtime, right? So we have to start factory reset this runtime and run it again. So this is the problem when we use this Google Colab and you use different platforms. You have to be aware about this versioning, otherwise you are going to get this in trouble. Right, now let's run all. All right, so now let's go down. I think it will be fine now. All right, so there is versioning problem. You have to be aware about that. So if you are using any Jupyter Notebook environment locally installed in your system, you are not going to see this problem. So no problem. Let's move forward here. We have split it. Now check the shape of this train and test. Alright, so check the shape of train and test here, and here to check the shape you can give print train shape. So just give here train shape, train shape, and here it is going to be our x train dot shape comma y train dot shape. All right, let's copy it and again paste it and change the variable names only. So let's paste this, make it to test shape, and here it is our test shape, and here it is our, again you have to make this as test shape. All right, let's run this. So here for training we have 120 data set, and for testing we have 30. All right, now let's move forward and build our model here. So build decision tree classifier. All right, so we are going to build this decision tree classifier here, and to do that, first of all you have to import it. So here from sklearn dot tree import your decision tree classifier, and here let's create a instance. So here I'm going to name it as model. All right, so this is our model equals to decision tree classifier, and here is our instance. So we are not going to tune these parameters here. All right, so here I'm going to fit my training data. So model dot fit, and here is going to be x train comma y train. Here we are fitting this our training model. All right, so x train, y train, and now let's run it. So shift enter. So we have built this model here. All right, the next step will be to do the prediction for training as well as testing here. So let's do that, and here let's do the prediction, predict for training as well as testing set. All right, So here we are going to give tr underscore predict equals to your model dot predict, and here you can give this your x underscore train. Similarly, let's do the prediction for testing. So ts underscore predict, it is going to be equals to model dot predict, and here it is going to be x underscore test here. All right, so we have doing the prediction, we have done the prediction here. Now the next step will be to check the accuracy of this decision tree, to check the accuracy for training as well as testing data. Right, so we are going to check the accuracy for training as well as testing here. So to do that, we have to import this first. All right, so from sklearn dot matrix import your accuracy score. All right, so here we are going to check the accuracy score for training as well as testing. So print training accuracy. So our training accuracy, and it is going to be equals to mod, here it is going to be your accuracy score underscore score, and here you give this tr underscore predict, comma, and here your y true label, that is train, and your prediction. All right, so we in y train we have the true label and tr predict is our prediction. Similarly, copy this cell, paste it, and here change the variable name, make it testing. So make it testing, and you have to keep this as ts predict, and this is going to be our y test. All right, and now let's run this. So here on training and testing we are getting 100% of accuracy. So we are doing a very good job here. Now if you want to see your decision tree that you have built using this model, what you can do is you can plot it. So here let's plot our decision tree that we have built. So let's plot our decision tree here, and here I'm going to give from, you have to import this package before plotting this. So from sklearn dot tree import plot underscore tree. So we are going to use this package to plot our tree here. Let's have a figure size. Let's define a figure size here, plt dot figure, and fixed size. So here fixed size is equals to, and it is going to be, let's say 15 comma 10. So we want a big figure here. All right, and here let's plot our tree. So plot underscore tree, here you can give this model name. So it is model, right? So we have this model comma, here you can give this field. So you can give field equals to true, and to show this you can give plt dot show here, and now if you run this you will be able to visualize your decision tree. So this is the decision tree that you have built here. So here you can see this is your x3 feature, and if you want to give this name, you want to see the name, not the x3 or y3, what you can do is you can give here feature names equals to x dot columns. All right, so here what are our feature are our whatever values we have in this x, right? So we are getting this x dot column name, variable names in x. All right, and now if you run this, here the first split is happening on this petal width cm. All right, and here you can check the Gini at the root node, the number of samples at the root node, and your value here. All right, and similarly you go after splitting. Here you have got a pure node, that is only you have this 40 of single species. Now here if you want to check the species, you can also give your class names as well. So this is how we plot this decision tree here. And if you want to save it, all you can do is here you can give plt dot save fig, and here you can give this decision tree name. So iris, I am giving it as decision tree. So iris decision tree here. All right, now if you run this, it is going to be saved as well as plotted here. And here if you see, we have given this save fig. If you click on folder here, you will be able to see that you have iris decision tree.png. So you can download it and use it for your documentation. Now we have also talked about that you can also check the important features using this decision tree, right? So let's see how we do that. To check it, you can give model dot feature importances. All right, so model dot feature underscore importances, and here if you run this, it is giving you how important these features are. So here you have this one feature, two features, so we are not able to see the name of the feature, right? And to see the name, what we can do is we can give this. So here I'm going to define df importance equals to model. So pd dot, we're going to create a data frame, and here it is going to be our features is to our x dot columns, comma, and our importances are going to be importances is going to be our model dot feature importances. And now if you print this df, so let's run this. So it is df underscore importances, and let's run this. All right, now you are able to see. So this is your more importance, that feature which is petal width cm. This is adding more importance in building this decision tree, or it is helping to classify the features. The most important feature is petal width. All right, so now that we have built all these models, right, and if we stop here, all our hard work is going to be wasted here. It is going to reside in this notebook only. Now what we do is we save this model, whatever we have built, right? We save this model and then use it for the real-time environment. All right, so real-time applications. So if I take some feature, let's say I give you some feature, let's say I give you sepal length, sepal width, petal length, and petal width of some iris, and I don't tell you what is the class here. Your model would be able to tell me, right? In real world, it should be able to tell me what is going to be the class, whether it is going to be Setosa, versicolor, or virginica, right? So now we are going to save this. So import pickle, right? So we are importing this pickle here, and now what we will do is we are going to save this. So import pickle with open, right? So with open here your file name, so you can give any file name that you like. Here I'm going to give it as iris underscore classifier, and you have to give this extension of dot pickle comma, here it is going to be write binary. So we are doing the writing operation here, all right, as f here. All right, so we have opened this. Now we are going to dump this model whatever we have built. How to do that? To do that, we give pickle dot dump, all right, pickle dot dump, and here you give this. So we have downloaded it, right? Now let's head back to our Virtual Studio Code or any other environment that you are using, either Spider or any idle that you are using here. So I'm going to go to this VS Code and make sure that you save this file in the same directory where you save all your files from this. So let's go to this Virtual Studio Code. So all right, Visual Studio Code, let's go there, and we have saved this file. And if you want to see, I have set the path here. I have this in documents, and in Python scripts I have this iris classifier dot pickle here. All right, so we have in the same directory where I save my all the files here. All right, so here we have iris classifier dot pickle. Let's go to VS Code. All right, just click on file. All right, so just click on file, then click on new file here, or you can do Control N. So click on new file, and here it says untitled 1, and here we are going to open our pickle file first. So here let's import the packages first. So import the packages. So import pickle, and then import from sklearn dot tree, import your decision tree, import decision tree here, decision tree classifier, and you have to save it first. All right, to save it you have to write Control S, and here you have to give the name. So here I'm going to give it as iris underscore app dot py. So make sure you give this extension dot py here and save it. All right, so now we have save it, and there is color coding here, right? We see that there is import has been colored, and you see this all these colors here. All right, now what we do is, here we are going to open our file. So here with open your iris species dot classifier, sorry, iris classifier dot pickle, comma, this time we are opening this with read binary. So we are reading it as f. All right, and here it is f is your clf equals to, it is going to be pickle dot load, and here we are going to give f. All right, so we are opening this iris classifier dot pickle, we are reading it. All right, now the next step will be to save it or do the prediction. So we are going to talk more about Streamlit here, and here I'm going to show you what does Streamlit do here. So here we have done this, imported all the packages, that is pickle, decision tree classifier. We have opened this pickle dot load our iris classifier, right? So we have opened this classifier. Now for the next step, what we do is we define a main function here. So def main, and this function is going to do all the work for building our web app. And here we give start this if underscore underscore name is double equals to main. So it should be double underscore underscore main, and this should be in strings main. Then this function is going to run here. All right, so let's give it here. So here we have def main, and here if I write st dot write and I give any value here, let's say st dot write iris classifier, it is going to, let's save it. So first, before running, you have to save it. So just save it, and here you give streamlet. So in your terminal here you have to give streamlet run your iris underscore app dot py and enter. So it is going to take some time and then it will run. So just wait for a few seconds. All right, so it is asking for email. It is your wish, you can give it or leave it like that. Just enter, and here is our Streamlit web app. So it is opening. Just wait for some time. So we are getting this invalid syntax. So let's go back. So I think we have made a mistake here, as it should be double equals to. So this is the mistake here. It should be double equals to here, right? So it should be double equals to. Let's save it. Let's head back for browser, close this and click on always rerun. So it is running. You can see it here. It is giving you option that it is running, and just wait for some time. It will run and you will be able to see here. So I don't know why it's taking so much time here. In the meantime, let's write our all the codes. All right, so here let's write it. We have the 4 inputs, right? That is, you should enter sepal length, sepal width, petal length and petal width, right? So you should enter this sepal length, sepal width, petal length and petal width. So here also make sure that you import this, import Streamlit. We haven't imported it, right? So import Streamlit as st, and now you save it, right? And now you write st dot write dot text, that is iris classifier. Let's save this, and now you go back, and here it is running again, and you see this iris classifier on your web app here. All right, so similarly, if you know this check boxes, select boxes and different type of this widgets that we use, you can easily build this web app. Let's say if you want to add title, all you have to do is you have to write st dot title. Right, so all you have to do is you have to write st dot title, and here you save it, Control S, then go back to your browser here. Here you see that this is in bold, right? So this is in bold. You can also add subheader, subtitle as well. So you check out the Streamlit official documentation. You will have a very nice documentation over there, and you can learn from that. Now here we need the 4 inputs from the user, right, to do the prediction, that is sepal length, sepal width, petal length and the petal width, right? So we need the 4 inputs. So here I am giving sepal length equals to, it is going to be st dot number input, and here it is our sepal length. So we are giving this name to this number input. All right, and if you run this, save this, Control S and head back, let's head back, you have this sepal length, right? And you have a number input. Either you can click on plus or minus and this value will increase or decrease, or directly you can type here. All right, so we have this sepal length. Similarly, we need the 4 number inputs, right? So let's just copy this, just copy it, paste it over here one more time, paste it and paste it one more time here. All right, and let's make this sepal length to sepal width. So this is our sepal width and this is going to be our petal length, and this is our petal width. So we have this as petal width here. All right, and let's give a name as well, heading as well. So I'm going to write st dot title, right? And this title is iris species classifier. All right, now let's save it, and now you go back to your browser here and you see you have this 4 input, right? You can give 4 inputs, so you have 4 number inputs where you can feed this number, what is the sepal length, you can give what is the petal length, you can give what is the petal length or petal width. Here you can also give all these variables. So we have 4 variables, right? We are taking the input of 4 variables and then we are doing the prediction. So let's move forward. Here, go to back to our VS Code, right? And now we are going to do the prediction. All right, so here, tab here, and to do the prediction, you can give it as prediction or result equals to, let's keep this as empty string. All right, and also let's remove this directly. You can give result equals to clf dot predict, and here you can pass this sepal length, sepal width, petal length and petal width. So it is SL, we are taking this input of petal length in and storing this in SL. So SL comma, let's change the variable name, we haven't done that, sepal length, sepal width, and this is our petal length and this is going to be petal width. All right, and here we have given SL SW comma PL, that is petal length, comma PW, that is petal width. Right, so we have this result. Now if someone clicks on this button, so take that, so here give a tab and here write a if st dot button. All right, so if st dot button, and this button is going to be named as classify or give it as predict. All right, so you are going to have this result equals to, so let's give an indentation here. Here result equals to clf dot predict and sl sepal length, sepal width, petal length, petal width, and it is going to give you the species. So here you have to write it. So we are going to write st dot success, and here your result, and let's save this, Control S, head back to our browser. Now I'm going to give some input here. Let's say here I give 0.2, here I give it as, let's say 5.0 something, and I give petal width, let's say 7.0, and this petal width, let's say I give it as 10.01, right? And now if I scroll down, I have a button which says predict. So if I click on predict here, it is giving us this result. So let me check, we are not getting this prediction. Let's go back. Oh, we have given this string here. You don't have to give this string. It should be this result that we are getting. All right, let's save it. Let's head back. It's going to rerun, and if you click on predict, here it is telling you that the class is 2, but we don't want this class 2, 3, right? We want the species, that is Iris versicolor, setosa, or virginica. So to do that, what we can do is go back, and here you can give this if statement. All right, so you can have this multiple if statement again, elif or if. So if st dot, so if result is double equals to 0, then it is going to display, so it is going to display this st dot success. If the result is double equals to 0, then st dot success, it is our setosa, right? So it is setosa. Similarly, you can give this elif result is double equals to 1, then this is going to be st dot success, and it is your versicolor. Right, and to give this else, the class is st dot success, and it is your virginica. Let's save it, Control S, head back to your browser, right? And here just click on predict, and here you have this class, right? You have virginica. If you want, you can add many more things in this web app. We have simply built a simple web app to do this classification. So here is your classification after giving all these inputs, that is sepal length, sepal width, petal length, and petal width. So we have built this web app so we can utilize it whenever we want, right? And if you know any cloud, Heroku or Amazon or GCP, you can deploy your model as well, right? So this is a simple web app that we have built using Streamlit. I hope everyone is clear about this, how we build this decision tree. So we have covered the theoretical part, we have also covered the coding part, how we build our model, and we have also built a web app for that, so that it does not resides on our Jupyter notebook only. All right, so I hope everyone is clear about this, and I want you guys to join our Facebook group. There we are going to have multiple live sessions. There are going to be engagements from experts, and there is going to be a lot of learning for you. I promise you that there is going to be a lot of learning from that group. You can join there, and also for our next session, we are going to cover the web scraping, that is how we collect the data from the web if there is no data present in your databases or the open data set that you see, that is on Kaggle or your UCI ML repository or different platforms. If you want to build your other unique project, how you can collect this data, right? First step should be collecting the data. Then we are going to come up with this another webinar on the data analysis path or EDA part, and there you are going to have a very nice session, how we collect this data, how we do the EDA. So I hope everyone will join. So just register for that and follow our page on Facebook or Instagram, and just click the subscribe option here so that you will be notified. We are coming up with many such good webinars for you guys. That is free of cost. You have to keep learning, right? All you have to do is you have to give the dedication for this 2 hours of your day, and I promise you that there is going to be lot of learning. So that's it from our